Okay, here we have a graph of the natural logarithmic function. Notice that the graph is always increasing. So is it monotonic?
Yes.
Yes. Does it have an inverse?
Yes.
Yes. What is the domain of this graph?
0 to infinity.
Can it be equal to 0?
No.
Oops. So the domain is 0 to infinity. What's the range?
Negative infinity, positive infinity.
Negative infinity to positive infinity. So what does that tell us about the domain of the inverse? It's going to be negative infinity to positive infinity, and what will its range be?
0 to infinity.
It will be 0 to infinity. Do you remember what the inverse of the natural logarithmic function is? E
to the x power.
e to the x. Okay, so the inverse of the natural logarithmic function is e to the x. And if we were going to graph that, since the logarithmic function goes through the point 1, 0, e to the x goes through the point 0, 1. Notice here the graph is approaching the y-axis, but on the inverse function it will be approaching the x-axis and then going to infinity. And so if I had graphed it correctly, you can see that they do reflect across the line y equals x. So f of x equals the natural log of x has an inverse, which is e to the x. And we talked about this last year in pre-cal, kind of early in the year though. But if this is true, if f of x is the natural log of x and its inverse is e to the x, then we know that the composition of the function with its inverse is going to be the natural log of e to the x, and that has to equal x. All right, this is one of those identity things that we talked about last year. Anytime you see the natural log of e to something, then these two always match. You could also use your properties of logs to figure out what it is. If that doesn't ring a bell, using the property of logs, we could say that x times the natural log of e, the natural log of e is 1, so it's equal to x that way as well. But you could save that step if you remember, because of the composition of an inverse with its of a function with its inverse, you always get x. By the same token, if we take the composition of the function with the original, or the inverse with the original, we would have e to the x, which is the natural log of x, and that's going to be equal to x. So again, you'll be using these ideas in the work. And so before we actually start taking derivatives and antiderivatives, let's look at how we can solve some equations involving this inverse function. Can you see that green okay? All right. All right, we've got, I want to solve 7 equals e to the x plus 1. Of course, you could take a calculator and put y equals 7 and y1 and e to the x plus 1 and y2 and see where they intersect. That's one way that you can solve it. But we can also solve this by taking the natural log of both sides. And if we take the natural log of both sides, we get the natural log of 7 is the natural log of e to the x plus 1. What is the natural log of e to the x plus 1? It's just x plus 1. And so x equals the natural log of 7 minus 1. And you can actually get a decimal approximation on this. It's approximately, and you could only do that with your calculator, 0.946. Okay, if you're asked to give an exact answer, or if this would be on a non-calculator portion, that's a legitimate answer. The natural log of 7 minus 1. If you had a problem, and we're going to go through this kind of quickly because we did do this last year. 4e to the x equals 83. What's the first thing you need to do? Divide by 4. Always isolate the e to the x term. So if we divide both sides by 4, we get e to the x equals 83/4. And then if we take the natural log of both sides, the left-hand side becomes what? X. Of course, you could expand this to be the natural log of 83 minus the natural log of 4, but there's no real reason to do that. You can get a calculator answer right here by taking the natural log of 83/4, which is approximately what?
3.032.
3.032? Okay. So those are pretty easy to do. Let's go the other way. Let's say that, move these out. We want to solve a natural log. Your book tells you to exponentiate both sides of the equation. In other words, e to the whatever on both sides. That's one way we can think about it, or we can think about just rewriting this as an exponential equation. The base is e, so it becomes e to the 5th equals 2x minus 3. And I think that's what I showed y'all last year. Or you can do what the book says, which is e to the natural log of 2x minus 3 equals e to the 5th. Well, the left-hand side is just 2x minus 3 equals e to the 5th. So you end up with the same thing. But if we just rewrite that as an exponential equation, we can solve it for x. E to the 5th plus 3 equals 2x. So e to the 5th plus 3 divided by 2 equals x. Of course, you could get a decimal approximation for that as well. All right. The natural log of x squared equals 10. Solve that. Okay, x is 148.413 approximately. Is that the only answer? Plus or minus? Because we get e to the 10th equals x squared, so whenever we take the square root, unless you're told specifically to limit your answers, you're going to have a plus or minus. All right. Questions so far? Pretty easy work. Let's talk about the derivatives. It was pretty easy to find the derivative of a natural log, and it is easy to find the derivative of an exponential function. If u is a differentiable function of x, okay, again, we want to say let u be a differentiable function of x. Then if we take the derivative with respect to x of e to the x, it's just going to be e to the x. But if we take the derivative with respect to x of e to the u, it's going to be u prime e to the u. So if we had the derivative with respect to x of e to the 2x minus 1. First, we look for the derivative of the exponent, which is what, Adam?
2x minus 1.
So what's the derivative of that?
Oh, the derivative of
So it's just going to be 2e to the 2x minus 1. I want to find the derivative of e to the negative 3 over x. 3 over x squared.
oh, e to the negative 3 over x.
E to the negative 3 over x. And you might see it this way, 3e to the negative 3 over x all over x squared. Either way is the correct way to express that. Going through this pretty quickly. Questions on how to find the derivative? Because today we're going to go ahead and work with the integrals as well. These are pretty easy. I don't know if I can erase that or not. Oops.
It's district, right? It's not gonna.
All right. So use a differentiable function of x again. The integral of e to the x dx is e to the x plus c. And the integral of e to the u du is going to be e to the u plus c. Notice that you have to have the derivative of u in your integrand, just like we did before. Sometimes substitution will help here. Sometimes you'll be able to do it without actually having to set up u equals and all like that. But if we have e to the 3x plus 1 dx, do I have the derivative of the exponent in my integrand?
No.
What do I need?
3.
We need a 3, so if I'm going to have a 3 here, I need 1/3 out here. Now I have du. So our answer is simply 1/3 e to the 3x plus 1 plus c. All right. We're going to take the integral of 5x e to the negative x squared dx. I'm going to, one like this threw some of you, I think, on a quiz or a test. You might want to, since 5 is not part of the derivative of the exponent, just move it to the outside. What's the derivative of the exponent? Negative 2x. So I need a negative 2x right here. Well, I have the x. So I need the negative 2 here. So I'm going to have a negative 1/2 on the outside. Not a lot different from what we'd already done before when we did substitution. Here we can recognize the pattern and you don't actually have to put u equals, but it doesn't hurt if you do. All right, so when we integrate, we get negative 5/2 e to the negative x squared plus c. So let's do a couple more just for practice, and I'll let y'all do them. I don't know why I can't move it. It won't move.
I don't think it's not moving. GIT?
All right, here we have the integral of e. What did I miss?
I don't think it is.
Okay. What'd you get? Is she right? Okay, we have agreement there. All right, let's try this one. The sine of x, e to the cosine of x dx. What is it? This one should have been a pretty quick one.
Yeah. Not getting
Taylor,
it. Is it negative e cosine x plus e?
is that what it is?
Yes.
Good. What did you not get, Hunter?
I just saw a trig function.
And froze? You should know better than that by now. All right, let's do some definite integrals. I think just a couple more and we'll be done. Don't you wish they were all this easy? Okay. If I integrate this, what am I going to get? Negative e to the negative x, and I've got to evaluate that at 1 and at 0. So we're going to have, sometimes it's easier to put that negative or a number right there outside and evaluate everything and then distribute. So if we have e to the negative 1 minus e to the 0, anything to the 0 is what?
1.
Anything to 0 is 1. So we have a negative 1 over e minus 1. There's an exact answer. And then you could get an approximate answer from your calculator from there. Okay, one more I want us to look at. Any questions on that one? Going through these kind of quick, but I think y'all can handle it. All right, from 0 to 1, e to the x, whoops, over 1 plus e to the x dx. Nope. This one might be easier to set up a u. What would u equal?
1 plus e to the x.
1 plus e to the x. And what's the derivative of u? Do I have the derivative? If u is 1 plus e to the x, the derivative is e to the x dx. Okay, and if I plug in a 0, 1 plus e to the 0 is 2. And 1 plus e to the first power is just 1 plus e. And we have du over u, which means we get what? The natural log of u, which is the natural log, in this case, of 1 plus e minus the natural log of 2. So I wanted to go over this so hopefully it would help you recognize that you've got the derivative of the denominator in the numerator. Anytime that happens, that you have the derivative of the denominator in the numerator, you're dealing with a natural log. Okay, I know we went through this kind of quick. What questions do you have? Or do you not know until you work some?
Yeah.
Okay. Should be pretty easy, though. This was easy enough to put the derivative and the antiderivative together, especially since you've already had practice with the natural log. Okay, the assignment is page 347. Section, I think this is section 5-4. 3 to 18 every third. Number 38, 40 to 60 every fourth, 61, and 96 to 108 every fourth.